In this video, we'll be covering structure and properties of matter for paper 1, made simple, clear, and exactly how the examiners expect it. Why do some substances melt easily, while others don't melt at all? Why do some conduct electricity, and others can't? And why do some break, while others bend? This isn't random, it all comes down to structure and bonding. If you understand this properly, this entire topic becomes easy marks across all papers. This is the most important rule in the whole topic. Stronger forces between particles means that more energy is needed to separate them, and that leads to higher melting and boiling points, which means the substances are harder. Weaker forces mean less energy is needed, so lower melting points. Let's apply that idea. In a solid, particles are closely packed together. When you heat it, you give the particles energy, so they start to move more and overcome some of the forces. This causes melting, turning a solid into a liquid. If you keep adding energy, the particles move even more until they fully overcome the forces and escape as a gas. This is boiling. When energy is removed, the opposite happens. Gas condenses back into a liquid, and a liquid freezes into a solid. We use a simple particle model to represent substances. Particles are shown as solid spheres, which helps us visualize how they behave during a change of state. But this model isn't perfect. It doesn't show the forces between particles, and in reality, particles aren't actually solid spheres. This is a common higher tier exam point. These are easy marks. Solid is S, liquid is L, gas is G, and aqueous means dissolved in water. If you forget these in an equation, you're literally throwing away the marks. Ionic compounds form a giant lattice structure. This is a repeating 3D arrangement of positive and negative ions, held together by strong electrostatic attraction in all directions. This is exactly how you should explain high melting points. There are many strong electrostatic forces between ions, and a large amount of energy is required to overcome them. That phrasing gets marks. Ionic compounds only conduct electricity when molten or dissolved. That's because the ions are free to move and carry charge. In a solid, they're fixed in a place, so no current flows. Simple molecular substances are made of small molecules. They have strong covalent bonds within each molecule, but only weak intermolecular forces between molecules. When these substances melt or boil, you are only overcoming the weak intermolecular forces. That's why they have low melting and boiling points. Polymers are much larger molecules made from long chains of atoms. Because they're bigger, the intermolecular forces are stronger, so they are usually solids at room temperature. Giant covalent structures are massive networks of atoms bonded together. Examples include diamond, graphite, and silicon dioxide. These substances have very high melting points because strong covalent bonds must be broken, which requires a large amount of energy. This is a classic exam question. Graphite conducts electricity because it has delocalized electrons that can move and carry charge. Diamond doesn't conduct because all electrons are locked in covalent bonds. Metals have a giant structure of positive ions surrounded by a sea of delocalized electrons. These electrons are free to move throughout the structure. This is why metals conduct electricity. The delocalized electrons move and carry charge through the metal. Metals can be bent and shaped because the layers of atoms can slide over each other without breaking the overall structure. Alloys are mixtures of metals. The different sized atoms distort the layers, making it harder for them to slide. That's why alloys are harder than pure metals. This is how you answer almost every question in this topic. Start with the structure, then describe the forces, then link to the energy needed, and finally, state the property. Pause the video and give this a go yourself. Don't just think about it, actually say the answer out loud. Use the structure, forces, energy, property method we just covered. This is exactly how it will appear in your exam. If you got stuck, this is the method you should be using. First, describe the structure, a giant lattice of oppositely charged ions, then identify the forces, strong electrostatic attraction between those ions. Next, link it to the energy. A large amount of energy is required to overcome these forces. And finally, link it to the property, which is why ionic compounds have high melting points. This is what a full mark answer looks like. Ionic compounds have a giant lattice structure of oppositely charged ions. There are strong electrostatic forces of attraction between the ions. A large amount of energy is required to overcome these forces. Therefore, ionic compounds have high melting points. If your answer looks like this, you're getting full marks. If anything didn't click for you, pause the video and go back through it. This topic is one of the easiest ways to pick up marks once you actually understand it, and remember, knowledge beats luck.